This is a summary of the second half of Chapter 1, where we delve more into Scrum as a method. So I'm going to skip over the first part of the chapter, which we covered, um, and go down here. So what we were left kind of talking about is some of these charts and metrics for analyzing Scrum. Um, And so we're going to look at some of these in different ways. The first thing we're going to talk about is a story point. So this is some measure of the effort required to implement a story, a user story. Um, it sometimes people try to equate it to a number of hours or something, but it varies from group to group, and so there's no standard way of assigning these. They're really meaningless outside the team that assigns them, but within a team they're relative to the other. So if one story has one story point, and another one has four story points, the second one should take four times longer than the first one to work with. Here's some actual times estimates for them. So something with one story point, something with two story points should take twice as long. Three story points, five story points, 8, 13. Now, notice these don't go up incrementally. You may recognize these as Fibonacci numbers. They're just a way of nearly doubling. Each one is made up of adding the previous ones together. So it just is a nice collection of them. I've also seen groups that just use 1, 2, 4, 8, 16 for the story points. We also want to watch the average story points that we can do during each sprint. Um, that should be a good measure of how effectively we're doing and if we're running into problems. So if we have a sprint that we just don't hit as many story points as we thought, we should be looking at some problems that might be underlying that issue. Okay, a couple of charts we're going to look at. One is a downward facing chart generally, and the other is going to be an upward facing chart. The sprint burn down is for one sprint, so it's often like a 2 week period running Tuesday through Monday. Again, we're often starting our sprints in the middle of the week. And so, theoretically, as the days go by, we should start with so many story points we need that are in that sprint, and every day we should be wrapping some of these up. And then, besides that, we often map the actual figures here. One thing I would certainly suggest is that you will tend to see first couple days not too many story points being done, because again, to get a story point done, you've got to learn more about it, implement it, and test it, and so that can take a couple days. So sometimes this is more flat for the first couple days, and then you'll see a drop down there. So. The other type of store or graph is a growing one, and this is longer term. So each dot here represents a sprint, where this is the whole graph is one sprint. Here, each dot represents a sprint, and this is just how many features or sometimes how many story points or whatever we're doing per sprint, and just showing the growth in features as we go. And again, we got to watch for plateaus. If you're plateauing and you're just not getting new features, then you've got to start asking what kind of issues are coming along there. So another artifact that we'll see a lot is these backlogs. So there's two different kinds of backlogs that we've mentioned before: the product backlog and the sprint backlog. The product backlog, both of these are stacks or sets of user stories that haven't been completed yet. The product backlog is every user story that hasn't worked its way in the product. And usually there's some method for customers or users to suggest features. There's some problem fixes. There's ways of generating new product backlog user stories. And then the sprint backlog is just the user stories that are in the current sprint that haven't been taken on yet. No one has done these. Okay, let's talk a little bit about the sprint itself. We'll generally like to start the sprint on Tuesday, Wednesday, or Thursday because of the way they are set up. The first day of the sprint and the last day of the sprint usually require a fair amount of meetings and discussions and stuff like that, and people generally don't want to be doing that on a Friday afternoon. So you don't want to be wrapping up your sprint on a Friday afternoon. You'll tend to want to skip over some important meetings and things like that. So we're usually starting in the middle of the week for these. We go through and do some estimation of our story points. First, we're looking at our features, and then the features are broken down in this user stories. So a feature can be one of a couple sizes, often like t-shirt sizes, small, medium, large, that sort of stuff. And priorities, required, deferred, or desired. So required are ones that we have to get into the sprint. And again, preferred and desired are less important for these. So we're going to look at a couple meetings. I'm going to jump down here just so we can see the overall layout of this. So here's a typical sprint starting on Tuesday. We start with a sprint planning meeting and we'll look at some of the things there. And then we have daily scrums every day during the meeting. At the end, we have a sprint demonstration, a retrospective, and often a planning meeting. And this planning meeting is the same as this one that starts the next sprint. And this is working on a 2-week sprint cycle here. Okay, so let's look at some of those things when we're starting a sprint. We're going to first try to have a planning meeting, a sprint planning meeting, get everyone together and look at the user stories, possibly select the user stories. And again, this will be everyone, business analysts, developers, test analysts, scrum master, product owner, everyone together. One way to try to estimate how much time these stories are going to be is just to have everyone guess. There's some basis to averaging a series of guesses as far as getting a good result from it. Often people are just given cards, playing cards or some other cards with numbers 1, 3, 5, Fibonacci numbers or some other numbers, and then everyone just holds up the card corresponding to what they think a user story. So you go user story by, here's a user story, someone describes it, and everyone votes at the same time, and you just average those out, and then you talk and make sure you can come to some sort of agreement on that. It's called poker planning because of this deck of cards, poker session sort of stuff. Another way of doing this is sometimes you'll just sort the stories, the user stories, in order from least complex or to most complex. So just take 2 stories and say which one's going to take the longest. Okay, put that to the right, and then you pick a new story and put it in the sequence. Is it before, after the first one, and where? So eventually you end up with a line of user stories with sorted with the quickest, the easiest ones on the left, and the ones that are going to take the most time on the right. But somehow you got to assign some sort of user story points to each of these stories so you can go through. So once you've got that done and you figure you're ready to start your sprint, then every day you'll have a daily scrum. This is where you get together. You all sometimes it's called a daily stand-up. Everyone stands up. Often you're working in a pod where all the desks are in an area. Everyone stands up and turns around and faces each other. And you just ask, you just quickly go through and what did you do yesterday? What are you doing today? What problems are you having? And go through it very quickly and update everyone. Some discussions on when you should be having this meeting. You don't want it too early because some people may not be there. Often if you have flex hours and a set time where people have to be there, let's say 9 o'clock, you can hold it at 9 o'clock or something like that when you're guaranteed everyone will be around. Okay, so another thing you have sometimes is these Nico calendars, this happy, medium, sad calendars, or where you just show how everyone's feeling every day. So some people use that as part of the stand-up routine. I haven't seen that in place, but some people apparently use that. Okay, now you go through and let's go back down here. I'm going to jump back down a little bit. So we had our sprint planning. We assigned story points to every story we're going to do and we're ready to start sprint. And then every day we have a daily scrum where we all stand up, face each other, and give updates. We do that now. When we're done with the sprint, we're going to do these things here. So the sprint demo where we're just trying to show off what did we get done, show off the features here. Often if there's a product owner or manager or sales team rep, we'll bring those in and demonstrate that. What's nice about having a demo scheduled is that it kind of locks you in. You can't say, oh, we need one more day for the sprint. You've scheduled the demo and you've got these people coming, so you've got to work to get these things done. The sprint retrospective again is useful. You want to just stop and talk what went well for the sprint, what didn't, what's working, what isn't, what do we need to be doing differently. So just spend a little time talking among your group on how to improve things. So now some places I'll do this triangulation where they try to say, well, what did we estimate on story points and how did it end up and that sort of stuff. Some people won't go into that much detail for these. So now, some problems with Scrum and Agile. It's interesting your textbook talks about these problems, but there's actually a lot of discussion. I think I've already seen this, and I see this frequently in online classes, where Scrum and Agile is not going to solve all the problems, and there's going to introduce some new problems. It's just a different way of developing software compared to the traditional waterfall method, and it certainly brings in some new features and allows us to do certain things, but it also introduces some new errors. Unfortunately, this part of the text does not cover that very well. Instead, it talks about just some software development issues we're going to look at. And these tend to creep in with either Scrum or with Waterfall method. But this is what our course is going to actually be dealing with is what are some ways of developing good software and what are some of the patterns out there for setting up good software. So some issues we have to look at. One is that code can get maladapted. You can create code where it's really hard to change the code later on. There's just standard issues we'll look at where the way you're doing things, the way it's set up, it makes it difficult to fix or change later on. It's very rigid and hard to do. Some examples of this is some lack of abstraction. In the next unit, we'll be looking at different using layers and some other ways of managing dependencies and hiding some things. This whole idea of abstraction. So when two sets of software are working together, one just sees some simpler representation of the other that they interact through, some sort of interface or some way of getting into that. And the details are hidden. And what's nice about that is if you do this right, you can change the underlying details without changing the simple representation here. We'll talk a fair amount about this mixed responsibilities and a number of things. We will want methods, classes, objects to have straightforward, discernible purposes or responsibilities. So you can say, well, what does that method do? And it hopefully just does one thing and one thing very well. And we have other methods do other things. We'll also talk about testability. There are ways of coding that make it very challenging to do good testing on the code, especially at the unit testing level, and we'll want to try this. You should assume that if code hasn't been tested, that it contains defects. You should always, assume all code contains defects, and we should be managing a process where we understand there's defects in code, and we're trying to minimize them and work around them and minimize the effect of those defects. So we'll talk more about unit testing later on. We'll have a whole unit for that. Another metaphor your textbook author brings in here is skyhooks versus cranes. This is just kind of the idea of, is something miraculously done or is it clear how this was developed? Here, and I'm not going to go into where this comes from, but skyhooks are kind of miraculous inventions where cranes are evolved abstraction or setups. So, and we'll be avoiding things like static methods and static classes. Right away in the next chapter, we'll talk about some problems with using new to declare objects and ways to maybe avoid that, like using interfaces and stuff like that. So we'll be having some of this stuff coming up in future chapters, and then we'll be replacing those methods or those kind of bad methodologies with some new ones. Like in 2 weeks, or 2 units, we'll be spending the whole unit talking about interfaces and defining interfaces, and then there's another unit on dependency injection and factories and stuff like that. So. Um, no. So there are metrics for measuring code out there uh, that we can often apply to see how good our code is. One is just unit test coverage. How much of our code is covered by unit testing that we are running, and are we running that regularly? Sometimes we measure some complexities. I've worked places where we've run software through complexity measures. It's kind of like I don't know if you've done this with any of your writing in school or other places, but sometimes you can take a sample of your writing, submit it like to a web page, and you say, "Oh, that's written at the ninth grade level or the 12th grade level, or the fourth grade level," because it just analyzes your word usage and stuff like that. Similarly, you can take code and run it through a system, and it'll count how many loops you have, how many condition statements, if, then, switches, that sort of stuff, and then how many embedded versions do you have, an if then, inside a while, inside a while. And certainly we don't want really complicated code in one method and stuff like that. I've seen I've seen if then statements that stretched over 5 pages between where the if and the else is, and loops, again, stretching over 5 pages or multiple screens of code. We want to simplify those, and we don't want an if within an if within a while, that sort of stuff. So there's a measure of that complexity. Okay, so that just kind of wraps up this unit on Scrum. So from now on, we'll be going into the actual code and looking at ways to rewrite or develop good, clean code that is usable in the long run.